Hey, what's up followers? Dave here from CNC3D. So in this video today, we're going to be taking a look at how to wire up one of our C3D THCs to one of our V2 Nighthawk controllers. So in the other video, which you may or may not have seen, where we showed you how to interface the C3D THC to a Nighthawk, we basically went through and showed you how to open the case to attach the little link cable that's in the middle there. And basically now we're going to take a look at how to do everything else. So we have this machine here. I'm just going to pan and tilt this camera a little bit to make things a bit easier for us. So let's just have a quick look. So we've got our plasma table just here. And basically we have everything hooked up to one of these SWS plasma cutters with a CNC port on the rear. For those of you that don't know, SWS is an Australian company that have basically been innovating plasma cutters and welders. And we're very excited to be able to use one of their SWS 50 amp units here for this particular setup. So let's just jump straight in and take a look at what we have done here now. So if you have a V2 Nighthawk and you have set everything up, basically everything that's happening on this Nighthawk end, so anything that is not in this little grey cable here, is basically just designed to control the machine. So that is a fairly standard thing as per our other videos for using the Nighthawk for setting it up. Basically all your stepper motors are connected, your limit switches are connected here, and that essentially will work with any type of system. It doesn't need to be a plasma system. It can be used for a router or for a laser or, you know, for whatever purpose you want to use it for. So the black wiring is all fairly standard and covered quite extensively in the Nighthawk manual. So definitely go through there to sort of figure this out. Now, just talking about the actual THC, so obviously we have our link in the middle there with that little grey cable that's bridging. We have a 4-pin connector over here on the THC, and then we just have these two wires. So basically all it really is that these two that are just here, they are basically used as the torch trigger. So that is on the plasma relay of the Nighthawk. And basically that's what's going to tell the SWS unit to turn the arc on and off. Now over here we just have 4 wires, and basically this is hooked up to the arc voltage signal, which is coming from the plasma cutter, and to the arc OK signal. So the plasma cutter basically will tell the THC that it has a good stable arc, and then the THC knows that it's good to proceed with the rest of the job. It also knows whether or not the arc has gone out prematurely as well. And obviously the arc voltage will also drop to 0 when that happens. So the THC constantly basically knows what the arc voltage is when it's lit. It also knows whether or not the actual plasma cutter is happy with its own arc. And that's really all it actually needs. So the rest of the control signals between the Nighthawk and the THC are actually done through that little connector there, so through the quick connect cable. So it makes things very easy. So just to summarize, we basically just have the torch trigger signal here, and then we just have the arc voltage coming from the plasma cutter and also the arc OK. Now for the C3D THC to work effectively, your plasma cutter must have a arc voltage divider built in, so it can't be a raw voltage. And basically it can be anywhere between 100 to 1 to 20 to 1. So common values are 100 to 1, 50 to 1, or 20 to 1. So if your plasma cutter is one of those 3, then it should be suitable for it. If you do have only a raw arc voltage output, then you will need to get a voltage divider in order to be able to make it work. We may look at designing one of these in the future just to help you guys out. There's just a few legalities regarding high voltage appliances that we need to go through. So that's basically the wiring in essence when you have a Nighthawk V2 and you also have a C3D THC. The wiring is extremely easy. Now, what we'll also talk about today here is we're going to talk about this plasma sliding assembly that we've created and what it's actually for. So in essence, the purpose of this plasma sliding assembly is so you can actually probe perfectly on your actual stock. So what it'll do is it'll come along to the first, it'll raise up from the 0, go to the first cutting point, go do and probe down on the surface and basically perfectly set at 0. Now this will occur typically every time the torch goes off and then needs to be reignited. It should do a probing routine in between, and that's what this little sliding assembly over here is intended to do. So basically this would come along and then this will probe up on here, and that's how it actually actuates. And so what it'll do is it'll travel along, it'll probe. What we might do now is just take a quick look at the menu items within the actual THC, and we can go and adjust from there. Okay, so we just have a close-up here of the C3D THC that we've just set up here that's attached to our machine. Now, we have just turned it off just so you can see what happens when you first power the unit on. Basically, we're just going to power it on right now. And so what we expect is it's going to tell us the current version of the THC. It's then going to go ahead and load up all of your user settings, and then it will immediately go into the Run Torch menu. Now, the Run Torch menu means that it's basically just ready to go. So all of the settings that you have configured within that THC, so you have to go through and do that, and we're about to do that very shortly. But as long as you are in the Run Torch menu, that means that the THC is ready to go and actually take control of your plasma cutting while it's running. If you are in any other menu other than the Run Torch menu, the THC will not actually do anything. So it's basically just in a configuration mode at that point in time. So just keep in mind that you always want to return back to the Run Torch menu. So we're going to use the back button here to take you into the main menu. And so you can see that it is the very top menu here is the actual Run Torch menu. So after you've done doing all of your settings changes, just go back in there, and that will basically allow you to start operating your C3D THC.
So in the Run Torch mode, if I click the back button here, this will go back into the main menu. When you're in this main menu, nothing is going to happen. The torch is not going to adjust its height. It's just simply going to allow Z commands to pass through from the controller. So if you do need to, whatever reason, run the torch without having this THC take control, you can do that when you're in this menu. As we go through these menus, we'll go through and have a look at each one of them. So we'll go down to the set target voltage here, and we'll click OK. In this menu, you can see we have a value here already. This is the voltage that the torch will hunt for while it is actively cutting. The higher this number is, the further away the torch will be from the steel as it's cutting. The lower this value, obviously, is the opposite. It'll be closer into the steel. If this number is set too high or too low, you might see some inaccurate or not nice cuts. So you do need to fine tune this value. We'll get to that a little bit further down this video. At the moment, I'm going to leave it at 1700 because this is good for my setup here. We'll go back and we'll go down to the next one here, which is set maximum voltage. Maximum voltage is the maximum voltage that the THC will read from the plasma cutter. This will usually only happen when the torch is all the way up in the air and not actually doing any cuts, or whether it travels over the edge of the stock or into a hole where there is no arc and it's not making any cut. For my particular plasma cutter here, my maximum is 2400 millivolts. To adjust these settings, all you need to do is up and down, which will change your value on the one that is flashing. We can go left or right to adjust those. To save that value, click OK. It will save the value and go back into the main menu. Next one down is read torch volts. So looking at this screen, we'll be using this in a very short minute, which will you'll need this for calibration, which we'll go through later. This reads the voltage that the torch is currently put out. My torch is not currently on, so we're not seeing any voltage there. We'll go down to the next one. The next one is set motor direction. So using this here, you can adjust which way the motor turns. So when you press the up button, your motor should go up. Down button should make the motor move down. So if I press this up, you may be able to hear that motor moving. Down is the opposite. You can change these values using your left and right button. If your up button makes your motor go down, use left or right to change it to the opposite. And we'll go back. Next one down is set motor speed. This is how quickly the THC will pulse the Z motor as it's moving. This is in microseconds. The higher this number, the faster the motor will move, but to a point it may become unstable. So usually 600 microseconds is a good number. If you need to, you can adjust these. Next one down is arc start mode. This is where you can change how the THC reacts when the arc is first ignited. We've got a few options here. Arc start mode, we've got dynamic, we've got none, and we've got alarm. Dynamic will be the default mode when you first receive your controller. What dynamic does is when the arc first ignites, it will look for that arc OK signal. If your plasma cutter does not have an arc OK signal, doesn't put out an arc OK signal, you won't be able to use the dynamic mode. But what dynamic mode does is once it receives that arc OK signal, it will resume the job. If the arc ignites and its torch is too high above the steel and it doesn't actually make that arc OK, what it will do is it will pause your currently running job and move the torch down until it receives that arc OK and the arc has been established. Then it will resume your job. It will send a pause and a resume signal to the controller. to resume the job. If, for whatever reason, the arc does not ignite, you are too high above the steel, or the steel wasn't able to make a good enough arc, it will send an abort and e-stop to the controller to stop the job. In none mode, all it will do is it will ignite the arc and it will not look for an arc OK signal. It will just continue going regardless of what the arc does. This is the mode you will use if your plasma cutter does not have an arc OK signal output. Mode alarm, what this will do is if it detects that the arc has ignited and you've got an arc OK signal, it will just continue the job as per normal. If you do not make an arc and the arc ignites but it does not make a good, there is no arc OK signal, there is no good arc, it will send an abort or an e-stop to the controller to stop the job. I'm going to leave mine in dynamic, and then we'll scroll down to the next menu, which is arc start delay. Arc start delay, so this is currently set at 3000 milliseconds, which is 3 seconds. This is the time that the controller will pause. If it has not received an arc OK signal within this time, it will send an abort or an e-stop signal to the controller. If it does receive an arc OK signal within this time period, it will resume the job. Next one down here is hole detection mode. Hole detection mode I currently have set to none. This is what the torch will do, or what the THC will command the torch to do when it detects either a hole or whether the torch has traveled over the edge of your material. In hole detect mode none, it will not do anything. All it will do is the torch may move downwards as it hunts the voltage. You may run into an issue where it hits the other side of the material, or if you've gone over the edge of the stock, it will just continue plunging down until either the plasma torch turns off and you lose the arc OK signal, or you intervene and something else happens. If we scroll here, we've got another option here, which is alarm. So hole detection mode alarm, if it travels over the hole or over the edge of the material, there is a delay, which we'll get to in just a minute. If it detects that it's still high voltage at this point, it will send an alarm signal or an e-stop signal to the controller to stop the job. So that will prevent your torch from crashing into anything else, but it will stop the job. In dynamic mode, this is the smartest mode. What it will do is if it detects a hole, so it's gone over the edge of a hole, it has dropped down, it's seen the high voltage, it will drop down. What it will do is go, okay, I've gone over a hole. It will pull the torch up a specified distance and continue the job until it reaches the other side of the hole. If it does not detect the other side of the hole, it does not detect the right arc, it will send an alarm signal after a delay, which is in one of the later menus. So we'll go back here, we'll scroll a bit further down. Hole alarm delay, this is what we were talking about just before. Hole alarm delay is how long it will detect those high voltages for before it sends the alarm signal. So this is 300 milliseconds, that's a very short time, which is usually pretty good. Holes, you don't usually go over a hole and you want it to stop pretty quickly if it does. So 300 milliseconds is the time that I've got set here. And we'll scroll down to the next menu. Set VH up pulses. So this is what happens when it detects voltage high, so that's what the VH stands for, and the amount of pulses it will step the stepper motor up. So this is if it detects a hole in dynamic mode, it will step this amount of pulses up. So this will depend on how many pulses your stepper motor needs to turn as to how far that actually moves. So this will move, so it'll go over the edge of a hole. As the voltage increases, as it goes over the edge of the hole, it will detect high voltage, which is what our torch maximum voltage is. When it reaches that, it will pulse this many pulses the motor up to move it up out of the hole and continue the job until it reaches the other side. Next menu down will be set max steps. So this is how many pulses the motor will move up or down from the start. So when the position it is when it starts. So this is a safety feature. So if you're, let's say, you got over the edge of the stock, but you're pretty close to the maximum travel on your Z-axis, you can set this value so that the Z-axis will not crash into itself. There are limit switch options on these machines, on these controllers as well. If you do not have the limit switches, this is your safer option. So this will only allow the THC to command the Z-axis to move up or down. In my case here, 5,000 pulses. So if you're, let's say you're very close to the edge of your Z-axis, you've gone over the edge of the stock, you don't have that alarm mode enabled, it will just continue to hunt downwards trying to find the voltage. It will only go down as far as your max steps down, which in my case here is 5,000 pulses. If it reaches that value, it will send an alarm signal to the controller to stop the machine from moving. Next one down is ignition delay in milliseconds. So ignition delay is the time that your plasma cutter takes to react to the on signal being sent from your controller. My plasma cutter that I've got sitting here is about 500 milliseconds. That actually might be a little bit higher, so I'm going to adjust this value. What this does is this, so all plasma cutters take time to ignite. So it takes time for the hardware to turn on the air, send signals to the controller to start, and then it takes time for that plasma cutter to react to that and ignite the arc. So in my case here, it's actually about 600. So I'm going to set mine here to about 600 milliseconds. If you set this to be a little bit higher, it's not the end of the world. It's actually preferably a little bit higher than a little bit low. That just adds a little bit of safety. So if you're not 100% sure, set it a little bit higher. Next one down here is LCD backlight. So this just adjusts the screen here. So if I can adjust that up or down to make it brighter or dimmer. I'll recycle back around. So 70 is a pretty good value, and that's what it will be set to by default. LCD contrast is the same thing. So this is adjusting the contrast of the screen. So as I adjust that, you might lose it on the video there. It just adjusts how well you're able to see that screen. So I'll leave it back where it was. And the last menu option down here, the last one or two menu options, they are just diagnostic. So you've got test inputs here. This will tell you what is currently coming from the controller to the THC and from the plasma cutter. At the moment, nothing's coming from it, so nothing's going to be sort of showing up here. But if you do things like test your limit switches or testing your inputs from the controller, this is the way that you can see what's going on. Last menu item on this list, we scroll all the way down to the bottom, is test outputs. So we'll get all the way down here. This is the same thing as test inputs, but this is all the things that the THC will send to the Nighthawk or to your controller. This will test all of the steps, all of the e-stop, the resume, and the pause signals. Test through cycling one by one. So be aware, if you do have your machine connected, you will possibly lose the connection as the e-stop is pressed by the THC. That is completely normal. So that's all of the menu options that we have run through here. The next step that we will do is we'll get the machine moving and we'll do some calibration. All right, so what we're going to do now is we're going to walk through calibration. So how to set one of these THCs up with your plasma torch. At this point, we do need to know that your machine is up and running. So if you are retrofitting or building a machine, you need to make sure that at this point it runs perfectly. So you've got all 3 axes movement, as well as your plasma torch and plasma cutter are set up ready to operate, because you will need to make a cut during the calibration process. All right, looking at the video here, we are in the run torch mode, so everything is turned on and ready to go. What we need to do is we need to move back down using the back button to the read torch volts. So we go into that screen there, and you can see that at the moment we have 0 volts, and you can see that everything there is ready for us to work. Something to be aware of is in this mode here, because we are not in the run torch menu, the plasma cutter will not move. So it will not adjust its height up or down. The THC will not control the Z-axis when we're in this menu. Looking at our actual machine now, we have our plasma torch positioned about to make a cut. I'm using some 6mm carbon steel, and I've got my plasma cutter set up and my plasma source is ready to go. Air is all plugged in and powered on. What we need to do during calibration is we need to figure out how much or what our target voltage should be. So what I've done is I have moved my torch down to the correct cutting height, and I'm going to make a cut 100 millimeters to the right across your screen. The THC will not adjust height, but it will show me on this menu, it will show me the voltage that it sees while it's cutting, and that's the voltage that I will need to set as my target voltage, which is the voltage the THC will hunt for as it's cutting to keep everything nice and clean and keep the torch at the same height above the steel regardless of how much it's warped. To do this, as I said, we are all set up ready to go. I'm going to make a cut 100 millimeters across the steel, and I'm going to read the voltage that it sees on the screen, and what it will show there on the top menu option, which is voltage. You've got voltage and you've got raw. We're only looking for the voltage reading here. Currently it's fluctuating between 0 and 3 millivolts, which is about right because the torch isn't on. As it starts traveling, it's going to move across the steel at about 100 millimeters at about 1,000 millimeters a minute. I want to try and get the voltage in about the middle of that cut. That's going to give me the most accurate reading. The voltages at the start and the end of the cut are going to be a little bit wild, so you want to look at the one that's right in the middle. So you want to look at the one that's right in the middle. That'll give you the best average of the voltages that it sees. So let's go ahead and make this cut. My routine that I've got set up here during my development, we'll do a little probe at the start. We'll go through the plasma probing is something that we've got a little bit later. But just for now, it's going to do a probe and then it's going to cut across 100 mil. And we'll read those voltages. Ready? Let's go. Alrighty, so now that cut's completed, I saw 1763, 1763 is the voltage that I saw in about the middle. So what we'll do is we'll use the back button and we'll scroll down to set target voltage, because that is the voltage that we want the target voltage to be. That's the voltage that we want at the correct cutting height for the steel. So we'll go to set target voltage. We've got it set to 1700 at the moment. If I change this to 1763, I can be super accurate with it. Otherwise, 1700 is a fairly good value. It doesn't have to be 100% exact, but we'll go 1763 anyway. 1763 done. Please wait, which means it's saved. So if I now go down to set target voltage, you will see it says 1763. That's the voltage that we have just set as the target voltage. We're going to do the same thing again. We're going to go back down to the read torch volts, which we have now done. So you can see on there, once again, we're fluctuating between 0 and a couple, which is fine because the torch isn't currently running. For this next test, we're going to do the exact same thing again, but this time we're moving the torch up off the steel. So I have moved that torch up 50 mil. So even though it doesn't look like it on the video, it's way too high above the steel. It's not actually going to make an arc. It's not going to do any cutting. So we're going to do the exact same thing again, but this time without an arc. This is finding the torch max voltage, the open circuit voltage where the torch is on, but it's not creating an arc. So all we need to do is we're going to do the same thing. Plasma cutters will, they have a bit of a safety feature in them. A lot of them do, where they will turn themselves off after a certain amount of time if it detects that no arc is turned on. If the arc is on, but it hasn't created an arc, it's not actually cutting, it's just up in the air, it will turn itself off to save itself. So you've got to be a little bit quick to have a look at what it says on the screen. Once again, we're looking at the voltage number, not the raw number. And we want to do it, we'll turn it on, give it a second or two just to sort of get itself nice and stable. Then we'll read what the voltage is, and that's going to be our maximum voltage. So we're going to do that right now. All I need to do is turn the torch on, go and read that number on the screen. Once again, remember that when you're in this mode, the torch will not automatically adjust its height, so it should stay nice and still while the torch is on. Here we go, we're going to read that voltage. There we go, it's turned itself off just because it had a certain amount of time where it wasn't actually cutting. And I was reading about 1950, 1900 is my torch max voltage. So we'll go back to our menu here, we'll go down to set maximum voltage and we can adjust this number. The default will be 2400. If you set this value too high, you might see issues with hole detection and with arc start detection, where it just won't detect an open circuit, so it may not enable those features if you have this voltage set too high. Having it set a little bit high is not a problem, so in my case, instead of changing it down to 1900, I'm going to set this to 2000. And okay, so just a little bit higher. That does give me a little bit of extra safety level there, just in case if your cutting voltage and so your target voltage and your maximum voltage are too close together, it can confuse the system. It's doing a lot of checks very quickly, and if it sees that voltage are a little bit too close together, it may misinterpret them. So having your torch max voltage set a little bit higher is not too bad. One thing to remember though is your target voltage will always need to be lower than your maximum voltage. So if you are seeing your maximum voltage during this test is lower than your target voltage, which we just set just before, you need to have a look at what's going on there. There's either an issue with the wiring, the way you've got it set up, or you may need to look at changing your consumable in your torch, as they will wear over time and cause those voltages to change. And that is one other thing to remember as well. If you drastically change things while you're cutting, so let's say you're normally cutting 3mm steel, you go to something like 9 or 10mm steel, you need to drastically up the current, you may need to redo this calibration for that steel. You may also need to re-go through this calibration when you are changing consumables, as that will also change the voltages that it sees. And if you start noticing inconsistent cuts, you start running your cuts. It's been running fine. You start doing some cuts, and the cuts start to look a little bit not so great. You're getting a lot of swarf. It's not cutting through. You may need to re-go through this calibration, as your voltages may have changed. So now that we've got those values set up, we've got our torch max voltage set, and we have our target voltage set. We've switched over now, and you can see it on the video there. We've got a fairly warped bit of steel on there, so we've just bent that one in a vise to exaggerate some warp. And what I'm going to do is I'm going to set this torch to cut a 200mm straight line from your left to your right along that screen, and you should see that torch tip follow the curve on that steel. On your other screen here, you'll see the screen of the THC, and you'll see what happens as it's cutting. So there'll be some diagnostics, some information showing on the screen as the torch moves. So you'll see any possible errors that will happen will show up on the screen, as well as just general information while the torch is cutting. So let's get this one ready to go. I'm already in the right position. We're already set up. All I'm going to do is turn the torch on and cut a 200mm line to the right, and you should see that torch follow that curve. Here we go. And there we go, that torch has completed that job, and there is a nice clean cut in that bit of steel.
Okay, so in this final part of this video, we're going to show you how you can interface with your C3D THC via our CNC3D Commander software. So this will basically allow you to configure the exact same settings that you can via the menus on the THC itself, but you can also go through and do firmware updates here as well. So as soon as we upgrade things, we're always working on things, we're always trying to make things better. What we'll do is we'll be pushing updates through, and it's a very easy process for you to be able to do it. So I've just gone ahead, obviously we've already pre-installed the USB driver on this machine. We've just got one of our C3D THCs connected up to here. So it will always show up as a USB serial CH340, because that is the USB chip that we use on the THC. So when you go to connect, and what I've done is I've actually rolled back the firmware on my C3D THC here, just to show you what to expect during a firmware update. So typically after a Commander update, you may actually receive an update for your THC as well. And it will also notify you, if you don't have a THC connected at the time, that you may have a potential update as well. So just keep an eye out for that too, and make sure that you do get regular updates for your C3D THC via the USB connection on the unit. So what we've done here is we've clearly just connected up the USB to our PC, and that's why we have this port here. So all I'm going to do is basically just hit yes on here to complete the update, and then you just need to hit the start button on this window here. So the screen will go off on the THC for roughly about 3 to 8 seconds as it does the firmware update, and then at that point in time it should come back up and give you the exact version that is on the THC very shortly. So in this case it should be 1.12, and then all you need to do is close out of here. Now if you do have the latest version of the firmware on your THC, you can just hit the connect button normally, and it will bring up this window here, which will tell you the version number that it currently has at the top. And basically all of the menu options that you have on the THC are in this section here as well, including descriptions about what the different types of modes are, for example with arc start, and also with the hole detection as well. Now if you're not sure what anything here does, you can always click on these little yellow boxes here, and it will tell you not only the actual like what it does, but it will also give you the minimum and the maximum values for it as well. And that applies to all of these in here. So this is a very easy way for you to be able to configure your THC without needing to go into any of the menus in here. Obviously, whatever changes you make in here, when you're ready to go, just hit the update settings option down the bottom here, and then basically close out. and you should be good to go. At that point, we definitely recommend that you pack away your USB cable because it's not actually required for you to operate the THC via USB. It will actually just go with the settings that are already on there. So this is just another handy little option that you do have for being able to configure your C3D THC when you receive it, and that is simply for you to interface it directly with Commander. Now, there is a quick little troubleshooting point for some of you that I would highly recommend that you do, and that is when you are about to connect to it, we do recommend going into the settings menu here and going into the communication tab, and just make sure that you have this use native serial library connected. If you do not have a tick in here, so make sure that you do have that ticked. If there is not a tick in here, please put a tick in there and hit update. It shouldn't impact a lot of you that are currently using the USB connection or the non-native serial library built into Commander, but this will definitely help you with any sort of connection issues to the C3D THC. It does just need to be the native serial port library. And that's pretty much it, guys. Other than that, based on this video, you should theoretically have your THC up and running right now, and it should be good to go. As usual, if you have any questions, please reach out to our support team, and we would be more than happy to help you try to resolve anything. Thanks, guys. I hope this video has been helpful for you. Have a wonderful week ahead.